Hello class, today we're on Module 16 and we're going over the Module 16 homework. So let's get right into it. We're dealing with function transformations here. So we have what we call a parent function, and then we manipulate the function to kind of transform it into something else. Here is our parent function here. And here is our image, our transformed function. So we need to list the transformations that are going on here compared to our f of x function. So first I see this 4 out front. And what this 4 does is it vertically stretches it by a factor of 4. So we can say there's a vertical stretch by a factor of 4. Next, we can say, well, this x right here, or this -3, this x minus 3, that's horizontally shifting the function to the right 3 units. Remember, when we are shifting left or right, it's the opposite of what the sign tells us. So if it's x minus 3, it's shifting it to the right 3. So it's a horizontal shift right 3 units. And then finally we have this +1, that's moving it up or down. So this is going to be a vertical shift up, this is +1, up 1 unit. Do the number 1 unit. There we go. And we want to write the transformed function in terms of the parent function f. So we can say h of x, that's our image here. H of x is equal to, well, it's equal to f of x, but what's going on to f of x? Well, there's this 4 in front. And it's f of x, but it's moving to the right 3 units, so we need to say -3. And then it's shifted up 1 unit. So I can say +1. So this is our transformed function in terms of the parent function. We have our original f of x. Well, h of x is equal to our f of x, but it's stretched by a factor of 4. It is shifted right 3 units and shifted up 1 unit. So next, we're given the parent function, and we're given the transformations of what is happening to that parent function. So it has a vertical compression by a factor of 0.3. and a vertical shift down by 2. So what I'm going to do is I'm going to take my f of x function here, and let's see, we'll call it g of x. And I'm going to say it's equal to, well, it's equal to our function, our parent function, the square root of x plus 1. But what's going on? Well, we're compressing it by a factor of 0.3. So that's going to be 0.3 out front. And then we're shifting it down 2 units, so it's -2, just like that. And then write the transformed function in terms of the parent function f over here. Well, we can say we have g of x is equal to our f of x, but we're compressing it by a factor of 0.3, and we're shifting it down vertically, down 2 units. So that's that. Next, we're given the parent function, and then we're given the transformed function in terms of the parent function. So let's first list what's going on here. So here, this is either a stretch or a compression, but since it's less than 1, it's going to be a compression. So it's a vertical compression, or I can say it's vertically compressed by a factor of 0.5. And then we're shifting right 2 units. So we can say a horizontal shift right 2 units. And then we have a vertical shift going on, and that's the plus 3. So vertical shift up 3 units. So how would we write our original function? Well, not the original function, the image of our original parent function. So we can say, okay, I have g of x, let's see, g of x, I just want to give myself enough room here, is equal to, let's see, we're going to have 0.5 because it's vertically compressed, and then we're going to have 2, but we're shifting it to the right 2 units. So I need my x, in the same parenthesis as x, I need minus 2 here. And let's see, it's cubed. And then minus 4. And then what else are we doing to it? We are raising it 3 units, so plus 3, just like that. All right. So next, we are given the image, and we're given the parent function here. The parent function is just x squared. And what are we doing to it? Well, here we're compressing it by a factor of 1/3. We're shifting it to the right 1 unit, and we're shifting it up 2 units. So I can say vertically compressed by a factor of 1/3. Then I could say it shifted right 1 unit. Or I could say, I could be a little more specific or a little more professional here, a horizontal shift. Right 1 unit. And then it is vertically shifted up 2 units. Just like that. Okay, and then we need to write the transformed function in terms of the parent function. So let's see, we're given as k of x and f of x. So k of x is going to be equal to, what are we doing to f of x? Well, we are compressing it by a factor of 1/3, and then we need our f portion, and we moved it to the right 1 unit, so it's going to be f of x minus 1, and then plus 2. Awesome. All right, so the next one we're just given the parent function and the transformed function in terms of the parent function. So the parent function here is an absolute value function. So what is happening over here? Well, it's being compressed, since it's less than 1, by a factor of 0.7, and it's being shifted left 4 units, a horizontal shift left 4 units. So we can say vertically compressed let's see, by a factor of 0.7, and we're also shifting it left 4 units. Awesome. And so now let's write our function. It's given to us as m of x. So we're going to have m of x is equal to, let's see, we have we are vertically compressed by a factor of 0.7, and then our absolute value signs, and we're shifting it left 4 units. So it's going to be x plus 4, just like that. All right, our last one. Here we go. A nice exponential for us. So we have a horizontal reflection. We have a vertical stretch by a factor of 1.2, and it's vertically shifted up 1.5 units. So let's talk about that in terms of the parent function first. So we're going to have our function. Let's just call it g of x. It's not given to us. G of x, let's see, is going to be f of x, but it's vertically stretched by a factor of 1.2. F of the horizontal reflection, that's going to be a negative x here, and then a plus 1.5. So how is that going to look just as the actual function? Well, let's see here. We're going to have g of x. Let's see, this might be a little long. G of x is equal to, let's see, we're going to have 1.2, and then we're going to have our f of x function, 3.7 times 1.07 to the negative x power, because we discussed that the negative x is going to give a horizontal reflection, and then plus 1.5. Oh, forgot the end of my bracket there. All right, and that's that. That's Module 16 homework. Hopefully this helped. Have a good day, y'all.